Hello everybody, and welcome to the very first video of the semester for us. In this first section of our course, we're going to be talking about integration by substitution, and this is a technique that many of you might have learned at the very end of Calculus 1. We're going to review it because this technique will play a very central role in our course this semester. Okay, so I think the best way to start this off is to just look at an example. Okay, so we're looking at page 4 in our workbook here. And example 1 would like us to calculate the integral of x times sine of x squared plus 5 dx. Okay, now, first of all, let's remind ourselves what that means. They are asking us for an antiderivative for the function x sine of x squared plus 5. Okay, and before we dive into this, I want to just flip the pages here and look at a list of common integral formulas that you generally learn in Calc 1. Okay, here's the big list of kind of common antiderivatives. And what you'll notice is that even though there are a lot of formulas on this list, none of them match the exercise that we looked at on the previous page. So if we want to do that integral, we need to somehow transform it into a form that's going to allow us to use this list. All right, U substitution is a way of doing that, taking an integral and turning it into an easier, more manageable integral. Okay, so here's how the process works. We're going to notice that this x squared plus 5 is inside of the sine function, and so we're going to let that be U. That's the substitution that we're talking about. After you choose a U like that, the rules of the game are the next thing that you do is to take the derivative of that U. So derivative of x squared plus 5 is 2x, and we're going to stick a dx on the end of that. So 2x dx. And then we're going to algebraically get the dx by itself by dividing both sides by 2x. Okay, when you do a U substitution, those first few steps are always going to look the same. Okay, and the idea then is to take these two pieces, the u and the dx, and to substitute those into our integral. All right, let's see how that looks if we do that. So the integral that we started with, okay, if we fill those pieces in, the x squared plus 5 is a u. We made that choice, so our integral becomes x sine of u, and then the dx that we have here, we can look up at our work and see that the dx is equal to du over 2x. So we just made two substitutions into our integral. Okay, and then we look at that and ask, does anything cancel? Notice that there's an x in the numerator and the denominator, so we can get rid of it. And that's a really good sign. When we use this technique, we'd like all of the x's to go away. Okay, and what's left over is just an integral that has u's in it. We might also notice here that there's a 2 in the denominator. That's a constant, and so we can pull that constant outside of the integral as a 1/2. Okay, so notice what we have so far. We have a new integral. Okay, actually it's equal to the old integral, but we've just rewritten it. It's got the new variable in our integral is u, and notice that it's quite a bit simpler than the one that we started with. Okay, it looks a lot better than the integral that we started with at the beginning of the problem. Okay, let's take another look at that list of common Calculus 1 integral formulas. And notice that the integral that we have basically matches formula 4. Okay, our integral has u's in it, but it's the same form. We're trying to find an antiderivative for sine, and formula 4 tells us antiderivative of sine of u is negative cosine of u. We change that x to a u. So we can go back and say with confidence that our antiderivative here is negative cosine of u. Since it's an indefinite integral, we're going to put an arbitrary constant at the end. Okay, and the last step here is just to switch our variables back to x's. Okay, so looking back at our work, u is equal to x squared plus 5, so I'm going to resubstitute x squared plus 5 in for u. Okay, and there's our answer. That should be an antiderivative of the function that we started with. Okay. So I want to say a couple of words just in general about this process to conclude this video here. Okay, so you'll notice right above some comments on the substitution rule and how it works. Let's fill this in together. So the first comment, when making a substitution, the goal is to transform an existing integral into an easier integral that we can then evaluate. That's exactly what we just did. We started with this integral, and by making a substitution, we transformed it into an easier integral that we could go back to our list of Calculus 1 formulas to do. Okay, and then number 2 is just some general advice on how do you pick that u when you use this method. Okay, so 2 tips that I can give you. Choose u so that the derivative of the u appears in your integrand. Okay, that's generally a good sign if that happens. Okay, and then part B, choose u to be the inside portion of a function. That's a good general rule. That won't always work, but will work a lot of the times. And notice that's exactly the strategy that we used in example 1. We chose u to be x squared plus 5 because it was inside of the sine function.